Good afternoon. We're in section 3-4 of the differential equation book. What I would do if I were you is do the homework and not bother to read this chapter. Most of what's in this chapter is not relevant to us. Consider it as more practice solving the problem, because we're just going to do problems. You have to do 1 through 7, and I'm going to do the even ones. So, but it is weird, so that means we can expect to have, we don't, Frobenius method only guarantees us one solution, so we might find that we only have one, and we might find that the solution is relatively weird. So those are things that we expect. And next class period is the Chapter 3 test. So Chapter 3 test is on Thursday. Okay, problem number 2, x, y, double prime plus 5 minus x, y prime. Now, I'm not doing well here, am I? I think I'm touching a part of my pen that I shouldn't be touching. X, y, double prime plus 5 minus x, y prime minus y is equal to 0. And we'll see if we can clean that up some. All right, that looks better. Minus y. Right? Okay, and we're using Frobenius method, so we have x summation n equals 0 to infinity n minus r, n minus r minus 1, a n x to the n minus r minus 2 plus 5 summation n equals 0 to infinity n minus r, a n x to the n minus r minus 1. Yeah. Minus r, n minus r minus 1 minus x summation n equals 0 to infinity n minus r, a n x to the n minus r minus 1 minus summation n equals 0 to infinity a n x to the n minus r is equal to 0. Okay, running out of room very rapidly here, which is going to cramp our style considerably. I'm going to bring the x in, the 5 in, the minus x in, and I'm going to rewrite this summation n equals 0 to infinity n minus r, n minus r minus 1, a n x to the n minus r minus 1 plus summation n equals 0 to infinity 5 n minus r, a n x to the n minus r minus 1 minus summation n equals 0 to infinity n minus r, a n x to the n minus r minus summation n equals 0 to infinity a n x to the n minus r is 0. All right, now we're going to want to have all the indexes be the same. All the exponents be the same. So I got an n minus 1 minus r minus 1, another minus 1. These guys are okay. So I'm going to do a substitution in this guy, n equals n plus 1. And I'm going to do a substitution in this guy, n equals n plus 1. And I'll keep the other two guys the same. All right, so I've got summation n equals minus 1 to infinity, n plus 1 minus r, n minus r, a n plus 1, x to the n minus r, plus summation n equals minus 1 to infinity, n plus 1 minus r, a n plus 1, x to the n minus r, minus summation n equals 0 to infinity, n minus r, a n x to the n minus r. Wow, that's really bad. Minus summation n equals 0 to infinity, a n x to the n minus r is equal to 0. Okay, now I want to remove the n equals minus 1 guy out of that summation, and the n equals minus 1 guy out of this summation, and then I'll make one giant summation starting at n equals 0. Okay, so that's the plan. And so when n is minus 1, this is going to be minus r, minus 1 minus r, a to the 0, x to the minus 1 minus r, plus minus r, a to the 0, x to the minus 1 minus r, plus summation n equals 0 to infinity, and we'll throw in a couple brackets, n plus 1 minus r, n minus r, plus n plus 1 minus r, a to the n plus 1, and then we're going to have minus, and we'll throw in a bracket, n minus r, and because we've made it negative on the outside, it's positive on the inside, so that'd be plus 1 a n x to the n minus r is equal to 0. Okay. So when I look at the x to the minus 1 minus r term, I get that minus r times minus 1 minus r plus a minus r has to be 0. So you have an r squared, and I have a r, and I have a minus r is equal to 0. So it looks like I've got r is 0, so r is equal to 0, which immediately begs the issue, if r was equal to 0. So at this point, the correct thing to do is to look in the back of the book to see if r is equal to 0 is correct, because we don't want to go on if in fact r is equal to 0 is not going to give us an answer. And r equal to 0 is not going to give us an answer. So that means we have to find our mistake. Bummer. And I know where it is. So that's the good news. You know where it is? You can see the whole problem because you got it all written down, right? I can't see where it is. I know where it is, but I can't see where it is because I can't see that far up. But I remember that there's a 5 here, and there's a 5 there, and there's a 5 here, and there is not a 5 there. See that 5 right there? And without that 5 right there, that sort of hoses me over pretty bad. So now where does that 5 come in? So there's a 5 sitting here, right? There's a 5 sitting there. And then in the summation guy, there's a 5 sitting there. So that means there's a 5 sitting there. Okay, so that helps us out some. Before you walked in the room, I did mention that the Chapter 3 test is on Thursday, so you better get your act together. So I've got r squared plus r minus 5r is 0. So I've got r squared minus 4r is 0. R can be 0 or r can be 4. And r can be 0 or r can be 4. And I'm looking in the back of the book one more time, and I see that r can be 0 is an answer, but r equals the 4 is not an answer. Bummer. All right, so now we're going to have to go back up and see where we made our mistake again. Where else? If that were a 5, minus x, (5) minus x minus that guy, minus 1 minus r minus 1, that's minus 1 minus r, minus 1 minus r. Do I have minus 1 minus r there? Yes, I do. Did I do it right? So minus 1 minus r, minus 5r, 5 minus r, there's no minus sign there, minus r squared minus 5r, giving me r squared minus 4r. Yeah. So we'll assume the book is wrong, and we'll come up with a recurring formula. Right now, I don't see how I get anything other than a 4 there. But not being able to see the whole problem at the same time does have some issues. Okay. So we have a recurring formula. My recurring formula is a n plus 1. A n plus 1 equals, there's a minus sign there, so it becomes positive, n minus r plus 1 divided by an divided by n plus 1 minus r, n minus r plus 5 n plus 1 minus r. So that's my recurring formula. And it'll take a little bit of time to make it look pretty. A n plus 1 equals n minus r plus 1 a n. And I'm doing anything but making it look pretty. Okay, now I've got an n squared. I've got a n minus r minus nr. I have minus 2 nr's. I've got a plus n. I've got a minus r. I've got a plus r squared. I've got a plus 5n. I've got a plus 5. I've got a minus 5r. Is that what I have? N squared minus 2nr's an n, a minus r, an n squared. Yep, I think so. Okay, so I've got a n plus 1 equals n minus r minus plus 1 a n divided by, okay, I've got an n squared. I have a minus 2nr. I have a 6n. I've got a minus r plus minus 6r. I have a minus 6r. I've got an r squared, and I have a 5. That does not look promising, does it? Okay, so case 1. R equals 0. All right, recurring formula. A n plus 1 equals n plus 1 a n divided by n squared plus 6n plus 5. Okay, this bottom is going to factor n plus 1, n plus 5, right? Okay, so a n plus 1 is a n divided by n plus 5. All right, well, now we have a recurring formula. We find that A0 is arbitrary, and this is for all n greater than or equal to 0. Why is that? Well, because the summation goes 0 to infinity. So that's why it goes 0 to infinity. Okay, A0 is arbitrary. A1 is equal to A0 divided by 5. A2 is equal to A0 divided by 5 divided by 6. A3 is A0 divided by 30 divided by 7. And A4 is A0 divided by 120, 210 divided by 8. Okay, so that's going to be A0 divided by 1680. All right, so my final answer says y of x is going to be A0 plus A0 over 5x plus A0 over 30x squared plus A0 over 210x cubed plus A0 over 1680 x to the 4th. Okay, so that's what my final answer is. Now we're going to check our work. And even when we get done checking, we only have half the answer because we still have to figure out why that 4 r is equal to 4 is sitting there and what that's going to do to us. We still have to figure that out. Okay, so we're going to check our work. Y is A0 over 5x, A0 over 30x squared, A0 over 210x cubed, A0 over 1680x to the 4th. Y prime is A0 over 5, A0 over 30 over 15, 15x, A0 over 70x squared, A0 over 840x cubed, and I'm going to need 2 of those guys, so I'm going to write down another one, y prime, A0 over 5, A0 over 15x, A0 over 70x squared, A0 over 890x cubed, and y double prime is going to be, that guy goes away, A0 over 15 plus A0 over 35x plus A0 over 3A0 over 890x squared. All right, now I'm going to want x of these guys. I'm going to want 5 of those guys. I'm going to want minus x of those guys. And I'm going to want minus 1 of them. And when I get done, I better have 0, otherwise I'm going to be very unhappy. Okay, so I'm supposed to have 0. Okay, so I got minus A0 plus A0. That term goes away. I've got minus 1/5, minus 2/5, minus 2/5, plus a third, plus a 15th. Is that 0? Okay, calculator's on. So I've got minus 1/5 minus another 1/5 plus 5/15 plus 1/15. That is 0. Okay, so this term goes away. Boom, 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 boom. Okay, next term. I got minus 1/30. I got minus 1 minus 1/30 minus 1/15 plus 5/70 plus 1/35. That's 0. And so that term goes away. Okay, the last term we can check. Minus 1/2 minus 1/70 plus 5/890 plus 3/890. That is not equal to 0. Okay. So is 1680 wrong? No. Silly. This is 4 goes into 1688. Let's see. 4 goes in there 4 times. How did I get a 2 there? 4 goes into there 4 times, 420, right? And then 420. And then 420 is can be divided by 3. And that would be 140, right? Okay, checking the last term. Minus 1/2 minus 1/70 plus 5/4 plus 1/140 is 0. So that term goes away. 0 is equal to 0, check. So our first guy is correct. Now, the back of the book says our second R should be a 2, not a 4. And so I'm dubious about whether or not I should even try to check out that other solution. And how in the world am I going to remember that? All right, well, we'll try it anyway. We'll assume the back of the book is not correct, and we'll do case 2, knowing that we're just going to be hosed. Okay, so on number 2, case 2, R is equal to 4. Right, so if R is equal to 4, our recurring formula AN plus 1, R is equal to 4, N plus 3, AN, divided by N squared minus 8N plus 6N minus 24 plus 16 plus 5. An plus 1 equals n plus 3 an. N squared minus 2n minus 3 Boy, it really would have been better to have a plus 3 there, wouldn't it? See, this guy's going to factor n minus 3, n plus 1, and I can't get rid of any of my things, so. But anyway, it is what it is, so that's all that matters. Okay, so A0 is arbitrary. A1 is 3 A0 divided by minus 3, which is minus A0. A2 is 4 times minus A0 divided by, n is now a 1. That's a 1. This is a 1 minus 4. A0, A2 is A0. Okay. A3 is going to be, this is now a 2, is going to be 5. A0 divided by, this is now a 2, 4, minus 4, 4 minus 4 minus 3. So A3 is minus 5 over that. Okay, and now we have A4. A4 is going to be 4, that's going to be a 3, that's going to be a 6, minus 5 over 3A0, and this is now, this is a 4, that's a 3, 3 squared, 9, 9 times, I'm dividing by 0. So at this point, I would say I have no solution. Because if I have to divide by 0, then I can't have a solution there. And the other thing I could do is say I don't have a solution until n is at least 4, which is back to the case 1 solution. So I think that's the way I would probably handle that one. I don't have a solution at r equals 4. Now the back of the book tells us we don't have a solution at r equals 4 as well, but we don't really care about how they got the other one. Okay. Number 4. Five x y double prime plus 30 plus 3x y prime plus 3y is equal to 0. Okay, how many steps do you want me to skip anyway? Summation n equals 0 to infinity. 5 n minus r, n minus r minus 1, a n x to the n minus r minus 1. plus summation n 0 to infinity 30 n minus r a n x to the n minus r minus 1 plus summation n equals 0 to infinity 3 n minus r a n x to the n minus r plus summation n equals 0 to infinity a n x to the n minus r is 0. Okay, so I want the same exponent, so I'm going to do a substitution in the first guy. N is equal to n plus 1, and a substitution in the second guy. N is equal to n plus 1. So I'm going to do both of those. All right, so are we cruising for a bruising on this one, gentlemen, or are we going to get this one right? Okay, so I'm doing these substitutions. Okay, so I've got n plus 1. So I got 5 n plus 1 minus r times minus r a. This has to be an n plus 1. No, I'm doing the substitutions. I got ahead of myself. I'm doing the substitutions. So I have summation n equals minus 1 to infinity 5 n plus 1 minus r n minus r a n plus 1 x to the n minus r plus summation n equals minus 1 to infinity 30 n plus 1 minus r n plus 1 minus r a n plus 1 x to the n minus r plus summation 0 to infinity 3 n minus r a n x to the n minus r plus summation n equals 0 to infinity a n x to the n minus r is 0. Okay, now I'm going to want to take the n equals minus 1 term out of that guy, the n equals minus 1 term out of that guy, and have one summation. Okay, so I've got 5 times minus r times minus 1 minus r. A 0 x to the minus r plus 30 minus r a0 x to the minus r plus summation n equals 0 to infinity and a couple brackets 5 n plus 1 minus r n minus r plus 30 n plus 1 minus r, a n plus 1 plus 3 n minus r plus 1 a n x to the n minus r is equal to 0. Okay, now I look at the thing that's outside of the parentheses. I can divide by a 0 because it's not 0. I can divide by a x to the n x to the minus r because it's not 0. And I'm going to have 5 r squared plus 5r minus 30r is equal to 0. I'm going to have 5r squared minus 25r is equal to 0. I'm going to have that r can be 0 and r can be 1. R can be 5. R can be 5. So r is 0 and r is 5. Well, that was a cool looking bracket, wasn't it? We're looking back in the book and we see that, yep, r can be 5 and r can be 0. Okay, so the author agrees that those are the two r's. Okay, so I got a recurring formula. And the recurring formula a n plus 1 is going to equal a n plus 1 is going to equal minus 3n minus r plus 1 a n divided by 5 n plus 1 minus r n minus r plus 30 n plus 1 minus r. Isn't that lovely? Okay, so we'll go with case 1, r is equal to 5. Okay, case 1, the hardest one. R is equal to 5. I have a recurring formula. A n plus 1 equals. Okay, so r is 5. I've got 3n, got a minus sign there. I have 3n minus 15 plus 1 for minus 14. A0. Okay. Okay, isn't that just so wonderful? So completely wonderful. On the bottom, I have 5 times n minus 4 times n minus 5 plus 30 times n minus 4. Okay, so I've got now I don't particularly like what's on top there because I can't factor anything out, but unless one of you tell me I made a mistake, I'm going to have to keep it for right now. Minus 14 A0. And on the bottom, I've got 5 5n squared minus 45n plus 100 plus 30n minus 120. Okay, an plus 1 minus 3n minus 14 a0 divided by 5n squared minus 15n minus 20. Do we want to keep it that way? Okay. Now we're going to go back and look at this top guy. Now it's problem number 5. So I need 2 terms an. How come I only have 1 term an? Oh, there's the other guy right here. So 3n minus r plus 1 an. Okay, so that's what I did. But. See this 3? See that 3 right there? You notice that there's not a 3 sitting right here, and there's not a 3 sitting right there. That doesn't violate the R thing though, and that means we need a 3 sitting right here. Okay, so if I have a 3 sitting right there, and R is a 5, so that would be minus 3 and minus 15. This is a 12, right? That's a 12. So that makes it a horse of a different color. 12, 12. Okay, so now I can do some factoring. So I have an plus 1 equals minus 3 n minus 4 n plus 4 an, and this can be a 5 times n squared minus 3n minus 4, right? Okay, I bring out the 5, 3, 4. Now I've got an n minus 4, n plus 1, and I still can't factor. Bummer. All right, so I can't factor, but at least I have something that's halfway decent. Okay, so that being the case, A0 is arbitrary. This is for all n greater than or equal to 0. A1 is minus 12, minus 12, A0 divided by, that's a 0, that's a 0, minus 20, 3/5 A0. A2 is minus 3 times, n is now 1. So that makes that a 5. 3/5 A0 divided by, n is now a 1, and a 1. So that's a 6. That's a minus 6. That's a minus 30. So 5 goes away, 3 goes into there 10 times. So this looks like 3/10 A0. Okay. A3 is minus 3. N is now a 2, so that's a 6. 3/10 A0 divided by, n is a 2, that's a 4. Minus 4 is 0, that's a 2 times 3, that's a 6. So I have a minus 30 on the bottom. Okay, so 10 goes into there 3 times. No, that 10 goes on the bottom, right? 3 goes into there 10 times. So it looks like I've got a 18/100 A0. Is that what I have? So I got minus 3 times 6 times 3/10 divided by minus 30.18. So yes, that's what I have. All right, so I'm going to do one more. Oh, do I really want to do one more? I really don't want to do one more, right? A4. A4 is minus 3 times 7 18/100 A0 divided by A4. So this is a 3. So 3 squared minus 3 squared, this is going to be a minus 20. Minus 20. Okay, minus 3 times 7 times 18 divided by 100 divided by minus 20, change to a decimal. That's so wonderful. 189/1000. Hardly seems reasonable. Okay, so my final answer, I'm going to have y is equal to A0x to the minus 5, right? Because r is 5, so it has to be A0x to the minus 5, plus A1, which is 3/5 A0x to the minus 4, plus 3/10 A0x to the minus 3, plus 18/100 A0x to the minus 2, plus 189 over 1,000 a0 x to the minus 1. Well, that was nice that I ran out of room. Okay, so now we got to check our work. Okay, so if y is a0 x to the minus 5, 3 over 5 a0 x to the minus 4, 3 over 10 a0 x to the minus 3, 18 over 100 a0 x to the minus 2. I wish it wasn't doing that. a0 1000 a0 x to the minus 1. Y prime. Well, this is number 4. Oh boy. 4. Okay, so I got minus 5 a0 x to the minus 6 minus 12 over 5 a0 x to the minus 5 minus 9 over 10 a0 x to the minus 4 minus 36 over 100. Why would we want to go 36 over 100? We wouldn't. We'd want to go 18 over 50 a0 x to the minus 3 minus 189 over 1,000 a0 x to the minus 2. Okay, and we need 2 of those guys? Yeah, we need 2 of those guys. Y prime equals minus 5 a0 x to the minus 6, 12 over 5 a0 x to the minus 5, 9 over 10 a0 x to the minus 4, 18 over 50 a0 x to the minus 3, 189 over 1,000 a0 x to the minus 2. Y double prime. 30 a0 x to the minus 7. 12 a0 x to the minus 6. Um, 18 over 5 a0 x to the minus 4 or 5. What is that? 40, 50, 54? 54 over 50 a0 x to the minus 4 plus 189 over 500 a0 x cubed minus 3. Okay, I want x, 5x. I want 5x in him. I want 30 of him. I want 3x of that guy. And I want 3 of this guy. Okay, so we're looking at the x to the minus 5 term. X to the minus 5 term. And I see I've got minus 15 and I've got plus 3. The x to the minus 5 term does not go away. which means our answer is wrong. Bummer. All right. I have minus 3 over 5. I have 9 over 50. So 9 over 50 is correct. So the 1's correct, 3 over 5's correct.
Either the 3x and the 5x get to go. And that y prime and the y double prime. Add in there.
No, because this is the minus 6 term. So the minus 6 term goes away. It's the minus 5 term that's not going away. And the problem is right here. So we got a problem up here. So the 3 over 5a0 is correct. Minus 3 times 5 times 3 divided by, when n is, when n is 1. When n is 1, this is 5. When n is 1, 1, 1, this is a minus 6. That's a minus 30. But I'm not supposed to be getting 3 over 10 for A2. For A2, I'm supposed to be getting 9 over 50. Okay, so I did that one in my head, right? Minus 3 times 5 times 3 divided by 5 divided by minus 30 is 0.3. So what am I doing wrong? When n is 1, that's minus 3 times 5, 3 over 5a0. When n is 1, 1, minus 7 plus 1 is minus 6. That's minus 30. How am I getting A2 wrong? I'm getting A2 wrong. And then my A3 is supposed to be my A2. Okay. When I factored out a 5, did I do that right? Yes, I did. Okay. When I factored out a 3, why is this a plus sign and not a minus sign? Anybody know? It's a minus sign there. It's a minus sign here. It's a minus sign there. It's a minus sign there. Okay, so this has to be a minus sign there. This has to be a minus sign. Okay. Now, when I go for A0 is arbitrary. A1 is going to be minus, n is 0. So that's going to be plus 12 divided by minus 20. That's a 0, that's a 0. Plus 12 divided by minus 20, which is going to be minus 3/5. Minus 3/5. Yes, minus 3/5. Okay, so minus 3/5 is right. When n is 1, this is going to be minus 3 times minus 3. Okay, so this is going to be a minus 3. This is minus 3/5. And I'm still going to have minus 30 on the bottom. So minus 3 times minus 3 times minus 3/5 divided by minus 30. Shit, no, that's right. I got the right thing. No, got the right thing. I want to change it to a, okay, so it's 9 over 50. This is 9 over 50 a 0. Okay, so now I've got a n is equal to 2. So when n is 2, this is going to be minus 3 times minus 2, which is a minus 6. So this is a minus 6. Minus 3 times minus 2 is a minus 6. Okay, and we're going to get rid of that. Okay, so I got minus 6 times 9 over 50 divided by, this should still be divided by 30, I think. So n is equal to 2. That goes away. That goes away. N is 2. This should be 15. No, n is 2. N is 2. N is 2. Minus 30 is correct. So minus 30 is correct. And we're going to have 6 goes into that guy 5 times, right? So we're going to have 9 over 250 a 0. All right, now, n4, a4, n is equal to 3. Okay, so a is equal to 3.
Isn't that 6 positive?
What?
That's 6, because you have a negative 2 and a negative 3, right?
Where?
That 6 that you wrote there for A3?
Yeah.
Shouldn't that be positive?
Negative 2, negative 3. So this should be positive, and that would be negative 9 over 250. Okay. And then we'll come back here. And we got minus 9 over 250. N is equal to 3. Okay, so 3 makes this a minus 1, makes that a plus 3. Plus 3. I'm negative on the bottom. I'm negative here. So 3 doesn't go into any of that stuff, right? So that's going to be 27 over 5,000 a 0. Okay, and those guys, and if I look at A5, what do? If I go to A5, n is equal to 4, this is 0, so A5 is going to be 0, and A6 is going to be 0, and A7 is going to be 0. So not only do I have up to A4, but I also know an is equal to 0 for all n greater than or equal to 5. Or 4, for all n greater than or equal to 4. Okay, no, 5. I was right the first time. Okay, so we're going to erase this garbage that didn't check. Because it would never check. And we're going to say check with backup book. Because it does check with the backup book. And now we're going to look at case 2. And that the case 2 is the n is equal to 0. So where's our recurring formula? There's our recurring formula. So we'll copy it. And we will paste it. Okay, so case 2 and r is equal to 0. Our recurring formula a plus 1 is equal to, so r is 0, so that's minus 3 minus 3 n minus 1 n plus 1 n plus 1. Okay, divided by an. Okay, r is 0, so I have 5n squared plus 5n plus 30n plus 30. Okay, so I've got minus 3 n plus 1 an minus 3 n plus 1. Wow. an, and on the bottom I got 5n squared plus 35n plus 30. If I take 5 out, I'm going to have 3n minus 1 an divided by 5 times n n plus 1 n plus 6. The n plus 1's go away, and I've got a 3 over 5 an over n plus 6. Oh, I hope I did that right. All right, so a0 is arbitrary. a1 is n is 0. 3 goes into there twice. 2 times that is 5. So that'd be a0 over 10. a2 is 3 over 5. a0 over 10 divided by, this is now a 1. So that'd be 7. 3a0 divided by 350. Oh, that's going to go up pretty fast, isn't it? And yeah, it looks like it goes up pretty fast. It says it's n times 5 factorial times 5 to the n. is what it says it's supposed to be. So that's going to go up pretty fast. We'll go with, probably only going to have to get one more. A3 is 3 over 5. 3A0 over 350 divided by 8. 3A0 divided by 5. 5 times 350 times 8. 14000. Well, the next guy is really big. All right, so we say that y is equal to A0 plus A0 over 10x plus, is this even possible? This can't be possible. Something's wrong. What's wrong? There's a minus sign sitting right here. Dum-de-dum. So there's a minus sign there, which makes this guy a minus, which makes that guy a plus, which makes this guy a minus. All right, so that'll help some. Minus A0 over 10 plus 3A0 over 3500. Oh, one too many zeros. Minus x squared minus 3A0 over 14,000 x cubed. Okay, if that's true, we should be able to check our work and see that it is. So we're going to check. We have that y is A0 minus A0 over 10 plus 3A0 over 350x squared minus 3A0 over 14,000 x cubed y prime. Do we need more than one? Yes, we do. Y prime minus A0 over 10 plus 6 A0 over 350x minus 9 A0 14,100x squared. Y prime, because we need two of them, minus A0 over 10, 6 A0 over 350x, minus 9 A0 14,000x squared. Y double prime. That guy goes away. 6 A0 over 350 minus 18 A0 over 14,000. Okay. We want 5x of him. We want 30 of him. We want 3x of him, and we want 3 of the other guy. And when we get done, we want to have 0. That's the idea. That's the whole point. So I have 3 A0s. I have minus 3 A0s. The A0 term goes away. I have minus 3/10. I have minus 3/10. I got plus plus 30 times 6 divided by 350, and I've got plus 30 divided by 350, and I get a 0, so the second term goes away. I'm looking at the x squared terms. I have 9 over 350. I've got plus 3 times 6 divided by 350. I've got minus 30 times 9 divided by 14,000. And I've got minus 5 times 18 divided by 14,000. And I don't have 0. Bummer. So there's probably something wrong with this term. But we're not going to go back and check because that'd be too much work. Now, we look in the back of the book for this guy, and what do they say for number 4? They say that it's going to be the first term is A0, but the next guy is going to be 24 summation n equal 1 to infinity minus 1 to the n, 3 to the n, x to the n, divided by, wrong guy. Oh, well, can't have everything. I was writing down number 3. Number 4, 120 summation n equals 1 to infinity minus 1 to the n, 3 to the n, x to the n, divided by n times 5 factorial 5 to the n. And the term that we messed up was which term? The A3 term. Okay, so we're looking for the A3 term, which would be n is equal to 2, I think. The A3 term is the A is a 0. No, n is, no, it'd be 3. So we're going to look at 120 minus 1 cubed, 3 cubed, x cubed, divided by 15 factorial 5 cubed. 15 factorial 5 cubed, that's a huge number. 15 factorial times 5 cubed. That's something times 10 to the 14th power. 120 times 27 divided by my answer. Wow, that's huge. Huge, huge. Anyway, so I would say, all things being equal, we don't have time to do number 6. What do you think? Yeah, considering that it's taking us so much time. So that means that gives us time to figure out what's wrong with number 4. So what did we do wrong to get A3? Okay, so A3 is n is equal to 2. So that's going to be, oh, why don't I have a minus sign sitting there? Okay, there's a minus sign sitting there, and there's a minus sign sitting here, so that's positive. But I should have a minus sign sitting there, but I have a minus sign sitting there. and n is equal to 2, so that, this, divided by n is 2, 8. So this should be a 9 on top. 9, 5 times 350 times 8. Okay, so that should be a 9 on top. And it should be minus. Alright, so that's 9 on top and it's minus. That's a 9 on top and it's minus. This is a 9 on top and it's minus. This is a 27 on top. 27 on top. And 2 times 27 is what? 2 times 27 is 54. All right, now we're going to look at the x squared term. Okay, so I've got 9 divided by 350. I've got 18 divided by 350. I've got minus 30 times 27 divided by 140,000. Okay, and I've got minus 5 times 54 divided by 140,000. Boom. I still don't get 0. Darn. Okay, I still don't get 0. I'm going to do it one more time. 9 divided by 350 plus 18 divided by 350 minus 30 times 27 divided by 14 with 3 zeros minus 5 times 54 divided by 1412 zeros. Boom. 0. Yay, calculator. That term goes away. And our problem now checks. Now we can go away. Now, Sunday, Wednesday, and Thursday is the test. There's 4 questions.